20. So if I use elimination method, I'll take this part here and that one on the other side. Then I can now multiply 3 times 2, which is 6y, minus 3 times 3, it is 9x, is equals to 18. Make sure that the 3 is multiplying on each value. Then 2 can also multiply here to have 6y plus 2x is equals to 40. So if we subtract, we are going to find that this side, they are going to be eliminated. These ones are going to be eliminated, this point here. So if I eliminate 6 and 6, this side it is done. And minus 9 minus plus 2. Okay, let me write it here. Minus 9 minus plus 2. A negative and a positive, if they're close together, it becomes a negative. Therefore, minus 9 minus 2, which gives me negative 11. So I'm going to have here negative 11x is equals to 18 minus 40. It is also a negative because 18 is a smaller number and 40 is a bigger number. We have negative 22. I divide both sides by negative 11 to remain with the x. Therefore, the value of x, it is 2. Then we can now substitute this equation for the value of x in any of the 4 equations that I have here. Any, even these ones, you can substitute any. So let us take 2y minus 3x, but in case instead of x, I'm going to write 2 is equals to 6. So 2y minus 6 is equals to 6. I bring this 6 this side so that 2y is equals to 6 plus 6, which is 12. Therefore, if I divide both sides by 2, I get the value of y to be 6. So it means that the point of intersection of this line in form of xy is going to be 2 and 6. That is the point of intersection. So if we can proceed now to the next part, you are told that a third line L3 is perpendicular to L2. So let us write down the equation of L2. We have a point here for L2, which is 3y plus x minus 20. This is the equation of L2. And this equation, it is perpendicular at point A. Find the equation of L3 in the form of y is equals to mx plus e. So first I'm going to find the gradient, because for the perpendicular lines we know that m1 and m2, the first gradient and the second gradient, is supposed to give you negative 1. So we will say, to remain with the gradient, I will have to make y the subject. Therefore, I'm going to return x and minus 20 the other side, so that my equation looks as 3y is equals to minus x plus 20. Then I divide both sides by 3 so that y is equals to negative 1 over 3 x plus 20 over 3. Therefore, this one here, we know that if this equation is in the form of y is equals to mx plus c, this one takes the position of m1. So m1 for perpendicular lines times m2 should give me negative 1. Therefore, I'm going to take negative 1 over 3 m2 is equals to negative 1. So if I divide negative 1 by negative 1 over 3, I'm going to find that m2, it is 3. That is the gradient. So we are going to say, because now I have the gradient of the perpendicular line, which is the key thing. And another point here we have to note that the points given are the point of intersection of A that we have already defined here. So therefore I'm going to say change in y, which is y minus, I take the points that I've gotten here, 6 over x minus 2 is equals to the gradient 3 over 1. So if I cross multiply, you can use any way that you can do it. So minus 6, then the other side I will be having, if I take 3 times the values at the bottom, we have 3x minus 6. Therefore, y is equals to 3x minus 6. I bring this negative 6 this side, so that I have positive 6. So a positive 6 plus 6 is 0. Therefore, y is equals to 3x. That is the equation of the L3 that they want. The next part, we are going to look at another part, that part C of the same question. Another line L4 is perpendicular. You see, this question was very good for a revising candidate, because for the first part, they were asking about the coordinates of a point of intersection, which is very rare. In most exam cases, it is asked as the last part. And the second part, they're touching on perpendicular line. Then on the third question, they're talking about the parallel line. So in short, they were trying to bring out the whole formula, the whole topic of equation of straight lines under one question. Therefore, for a candidate, because this question wasn't there last year, you are supposed to be expecting it. So let us look at this part of the question, part C. You are told another line, L4, is parallel to L1. So what is the equation of L1? L1, the equation is here. So I'm going to write it down, L1, which is 2y minus 3x minus 6 is equals to 0. So this is the equation that is parallel to L4. They are parallel on each side. Therefore, if an equation is parallel, if there's an equation of a parallel line, we are going to say, first of all, form this equation in form of y is equals to mx plus c, so that we can have our gradient. So it will be 2y is equals to, I take the other ones the other side, 3x plus 6. Don't get confused with the signs here. It's very key. Therefore, if I divide both sides by 2, y is equals to 3 over 2, x plus 2, 6 divided by 2, which is 3. Now, we take that one as our first gradient. And since it is parallel, the first gradient should be equal to the second gradient. Therefore, there is no change. And we have been given here the points. So what I have to do is to find the equation of the line, where I'll say y minus 3, because this is the y-axis, over x, a negative and a negative forms a positive, is equals to 3 over 2. So if I cross multiply, I'm going to have 2y minus 6 is equals to 3x plus 3. So 2y is equals to 3x plus 9, because